All right, so it says the variable resistor I naught is adjusted until the power dissipated in the resistor is 250 watts. So let's find the values of R naught that satisfy this condition. So we want to go ahead and pretend this R naught isn't there. So, and we want to find the voltage across, say, and we say that this is open, and then we want to find the I short circuit, and this will allow us to find the resistance across R naught, this variable resistor, when it's dissipating 250 watts. So I'm going to go ahead and redraw the circuit. Oops, that. $25 volts, 100. Okay, so do the loops. So we have I1, IX, and we know that RV Thevenin is the voltage drop across the 20 ohm resistor, and then the 30, the dependent source of voltage. So I go ahead and write the equations for this. So we have negative 200 plus 25 times I1 plus 100 times I1 minus IX equals 0. And then our second equation would be 100 times IX minus I1 plus 100 times IX, or 10 times IX plus 20 IX plus 30 IX equals 0. So we're going to plug that in. So 100 plus 5 by 1 plus 100 times IX 0 IX I1 plus 10 times IX plus 9 times IX 0 or 1. Okay, so you get the IX is equal to 2, and I1 is 16 over 5. Yeah. So knowing this, what IX is, I can say the volt VThevenin is 20 IX plus 30 IX, which is 50 IX, which is equal to 50 times 2 is equal to 100. So our VThevenin is 100 volts. Okay, knowing this, we can go ahead and find our I short circuit, right? So yeah, we're gonna go ahead and rewrite this. So we have 200 volts. Okay, so then we have 3 loops this time. This IX, I'm gonna call this I1, and then I'm gonna call this loop I short circuit. Right. So we write the equations. Scroll down. So I can say for our first loop with the I1 it's negative 200 plus 25 I1 plus 100 times I1 minus IX equals 0. 2, we have 100 IX minus I1 plus 10 IX plus 20 IX minus I short circuit plus 30 IX equals 0. Then for our third equation would be our I short circuit. So we have negative 30 IX plus 20 times I short circuit minus IX equals 0. So you can go ahead and plug this in. That's the equation. Start nodes. 200 plus 25 times I1 plus 100 times I1 minus IX equals 0. 100 times IX minus I1 times IX plus 20 times IX minus I short circuit plus 30 times IX equals 0. Negative 30 times IX plus 20 times short circuit minus IX equals 0. So we have I1, IX, and I short circuit. So then we get we want to know what I short circuit is. So it's 4 over 3, right? And we know our V Thevenin is 100. So our R Thevenin, right, would be 100 over 40 over 3, which is 100. Plug it in the calculator. 3, 7.5. So our Thevenin, or our Norton as well, 7.5 ohms, right? So then this was what our, so I'm going to draw an equivalent circuit now. So I'm going to say maybe Thevenin, which is 100 volts, and then 7.5 ohms, and then we have this variable resistor that we don't know. And so we have one equation because there's one loop, right? And I'm just going to call that I1. It's not erasing. Okay, so then our equation look like this, plus 7.5 I1 plus I1 times R naught equals 0. So I'm going to plug this into maxima. Again, with one equation, so it's -100 plus 7.5 times I1 plus I1 times, let me call it R equals 0. Then we want to find what I1 is, right? So I1 gives us this value. So it's 200 to R plus 5, I think, or 15, right? So this is where we go ahead and play with the power equation. So we know that power equals I times V, or I squared times R, or V squared over R. Right. So you just use I squared times R. So we know that power is 250 watts. And this equals to, is 200 or 20? Yeah, 200. Whatever. I'm going to make this more legible. 250, and then we know times R, right? Make it R naught. So again, I don't really want to do the math for this, so I'm going to plug this into this calculator, just because I'm running out of space. So 250 equals to 200 over 2R plus 15 squared times R. I want to know what R is. And 2 times R is 15. I'm actually going to go ahead and use an online calculator, like, just to make sure. So we have 250 equals 200 over 2. Let me call Rx plus 15. Times X. And it's going to solve for X. So is maxima right? No, there's two results for this. So I must have been doing something else. So R naught is either going to be, so R naught can either be 22.5 ohms, or where is it? 2.5 ohms in order for it to dissipate 250 watts. And yeah, this is these are the two values of R naught that satisfy this condition.